Welcome back to the deep dive. So, today we're talking about something absolutely fundamental. If you think about the applications you build as like the body of your system.
Then identity and access management, IAM, that's really the nervous system, isn't it?
Exactly. It's this strategic blueprint. It dictates not just who gets in the door, but what they can actually see or touch or change once they're inside.
And it's arguably the most critical piece for security, especially now with, massive scale and distributed systems, microservices particularly.
Right. And the source material we're drawing on today, it's less a gentle guide and more like, well, an architectural mandate, really.
It is. We're aiming to pull out the essential blueprint for a truly robust IAM solution. We want clarity, solid security, and the scalability you need for modern apps.
The goal here is for you, the listener, to walk away knowing where the real modern bottlenecks and vulnerabilities lie, and crucially, how to engineer your way around them.
Okay, so where do we start? Because the foundation of all this, it rests on two core ideas that our sources stress get mixed up constantly.
Yes. And that confusion leads to huge security gaps. It's authentication versus authorization, auth-n versus auth-c.
It really is the foundational mistake people make. Authentication, auth-n, it's purely about verifying identity. It just answers, who are you? Simple as that.
So when I type in my password or use my fingerprint.
Yep, the system's doing auth-n. That's your gatekeeper. Strong auth-n is vital.
Okay. And then authorization, auth-z. That comes next.
Right. Auth-z determines what you're actually allowed to do once you're authenticated. It answers, okay, you're in the building, but what rooms can you enter?
So authentication gets me in the front door. Authorization decides if I can access the server room or maybe just the coffee machine in the break room.
Precisely. And strategically, the smart move is a single centralized identity provider. Think, Microsoft Entra ID, Okta, things like that.
Why centralize the authentication part?
Because it gives you unified control. Audits become simpler. Auth-n really has to be the prerequisite for every single authorization check down the line. Centralizing it makes that manageable.
And something the sources really emphasize is that we're not just talking about humans logging in anymore. The scope is much bigger now.
Oh, absolutely. It has to be. IAM now covers human users, sure, but also non-human entities. This is critical.
Like what kind of non-human entities?
Devices, automated scripts, serverless functions, applications talking to other applications, service-to-service communication, all of that needs an identity.
So in a microservices world, those little services need their own IDs to talk securely.
They do. And whether it's a person or a piece of code, the guiding principle has to be the same. Least privilege. Only the absolute minimum permissions needed for the immediate task. Nothing more.
Okay, that principle of least privilege seems key. Let's talk about the cornerstone of identity verification for humans, though.
Yeah.
Passwords. The sources are pretty blunt here.
Never store them in plain text. Ever. Full stop.
Right. But securing them properly involves more than just not storing password 123 as is. It starts with hashing, right?
Yes, hashing. That's the one-way street. You take the password, run it through a mathematical function, and you get this unique string, the hash. That's what you store. It's irreversible.
But hashing by itself isn't foolproof, is it? I remember reading about rainbow tables.
Exactly. Hashing alone isn't enough against sophisticated attacks. That's where the SALT comes in. This is crucial.
The SALT, okay, explain that, because this seems like a detail that older systems might miss.
Right. It's a unique random value that you add to the password before you hash it. So let's say you and I both foolishly use password as our password.
Okay, terrible idea, but for the example.
Without SALT, the hash stored for both of us would be identical. An attacker cracks one, they crack both instantly.
Oh, I see.
But if we add a unique random SALT to your password before hashing and a different unique random SALT to my password before hashing, then the final stored hashes are completely different, even though the original password was the same. Exactly. Now, the attacker has to crack each one individually. It makes brute forcing or using pre-computed tables way, way harder, exponentially harder. And that SALT must be unique per user, stored alongside the hash.
Okay, so unique SALT per user, absolutely critical. Now, what about the hashing algorithm itself? Are we still talking MD5 or SHA-1? Please say no.
Oh, definitely not. Those are broken. For modern apps, especially cloud-native ones, the recommendation is clearly Argon 2.
Argon 2. Why that one specifically?
It's designed to be memory hard. It resists the kind of parallel processing power you get from GPUs, which attackers love to use for cracking.
Makes sense. What if you have compliance requirements, like government standards, FIPS, or NIST?
then PBKDF2 HMAC SHA 256 is generally the preferred, safer bet, but you have to tune its parameters carefully.
And that tuning, that leads to this core trade-off, doesn't it? The work factor.
It does. You're balancing security against user experience. Increasing the work factor means the hashing takes longer, uses more resources. That's great for stopping attackers.
But bad if your legitimate users have to wait 5 seconds every time they log in.
Precisely. You need to make it computationally expensive enough to deter brute force attacks, making billions of attempts infeasible, but not so slow that it frustrates your actual users. It's a constant balancing act.
Okay, so we've authenticated the user securely. Now, how do we manage that logged-in state, especially in distributed systems like microservices, where traditional server sessions don't really scale well?
That's where we move away from stateful server-side sessions and towards stateless, self-contained tokens, specifically JSON Web Tokens or JWTs.
Ah, JWTs. We hear about those all the time.
They're incredibly useful because they carry the user's identity information inside the token itself, cryptographically signed. The server receiving it can verify the identity without needing to call back to a central session store. Perfect for microservices.
But the strategy for using these tokens is critical, right? You can't just issue a JWT that lasts forever.
Absolutely not. That's a huge security risk. The core principle here is access tokens must be short-lived, very short-lived.
Okay, like how short? Minutes.
Yeah, think 5, 10, maybe 15 minutes max. This minimizes the window of opportunity if an access token is somehow compromised.
But wait, if my access token expires every 10 minutes, does that mean I have to log in again constantly? That sounds like a terrible user experience.
It would be. That's why you have a two-token system. You have the short-lived access token, and then you have a long-lived refresh token.
Okay, explain the refresh token's role.
The refresh token is stored more securely, perhaps in an HTTP-only cookie or secure storage on a mobile device. Its only job is to periodically and silently request a new short-lived access token from the authentication server.
Ah, so the user doesn't see this happening.
Correct. As long as the refresh token is valid and secure, the application can seamlessly get new access tokens behind the scenes. The user stays logged in without constant interruption.
That makes sense. The refresh token is like the master key kept safe. The access token is the temporary pass you use day to day.
Exactly. Get that strategy wrong, and your system is vulnerable no matter how good your initial authentication was.
Okay, so we know who the user is, authn, and we have a secure way to represent that identity with tokens. Now we get into the really complex part, defining what they can actually do. Authorization, authz. The sources map out a clear evolution here.
Yeah, it starts simple and gets progressively more flexible and complex. The most basic model is the access control list, or ACL.
ACLs. That sounds like a list on a file saying Alice can read, Bob can write.
Pretty much. Permissions assigned directly to individual users or objects. Simple concept.
But the downside is scalability, right? If you have thousands of users and hundreds of resources.
It's a nightmare. You're managing permissions individually, doesn't scale beyond very small systems, leads to errors, inconsistencies, just messy.
Which is why the industry largely moved to role-based access control, or RBAC.
RBAC. Much better. You group permissions into logical roles, admin, editor, viewer, whatever makes sense for your application. Then you assign users to those roles.
So instead of giving Alice 50 individual permissions, I just give her the editor role, and she inherits all 50.
Exactly. Much easier to manage, especially in medium-sized organizations. You manage roles, not individuals.
But RBAC has its limits too, doesn't it? I've heard the term role explosion.
Oh yeah, that's the classic problem. What happens when you need really specific permissions? An editor, but only for the marketing department. Or a viewer who can also approve documents, but only on Tuesdays.
You end up creating tons of very specific roles, like marketing editor or Tuesday Approve reviewer.
Right, you get hundreds, even thousands of roles. It becomes almost as hard to manage as ACLs were, just with different labels. The granularity isn't quite there.
So for that really fine-grained dynamic control, we need something more powerful. And that leads us to attribute-based access control, or ABAC.
ABAC is where things get really interesting, and frankly, where modern systems need to be heading. Access isn't determined by a static rule, but by attributes.
Attributes of what?
Attributes of the user, like their department, seniority, location. Attributes of the resource being accessed, like its sensitivity level owner. Attributes of the environment, like the time of day, the device security status.
Wow, okay. So you could write a rule like, allow access if the user is in finance, the resource is tagged confidential, and the time is during business hours.
precisely that kind of dynamic rule. ABAC offers incredible flexibility to model complex real-world security policies.
That sounds amazing for handling complex scenarios, but it also sounds incredibly complex to set up and manage all those attributes and rules. Is that the catch?
That is definitely the challenge. Implementing pure ABAC from scratch can be very complex, which is why the pragmatic recommendation from the sources is often a hybrid model.
Hybrid, meaning combine RBAC and ABAC.
Exactly. Use RBAC for the broad strokes, the main organizational structure. Assign baseline permissions using roles like engineer or sales. Then use ABAC to handle the exceptions, the fine-grained rules, the context-aware stuff.
So RBAC for the 80%, ABAC for the tricky 20% where you need that dynamic control.
That's a good way to think about it. It gives you a manageable structure with the flexibility you need for modern security demands.
This shift towards dynamic rules and attributes, it feels like we should be treating the security policy itself more like code.
We absolutely should, and that's the driving idea behind policy as code, or PLOC.
Policy as code, so like version control for your security rules. Testing.
Yes. Treat your authorization policies like you treat your application code. Store them in Git, have review processes, implement automated testing. It brings rigor and manageability to complex policy sets, especially with ABAC.
And there's a specific tool often mentioned here, right? OPA, Open Policy Agent.
OPA is a major player in the PASI space. It's essentially an engine that evaluates policies written in a declarative language called REGO.
How does it change things for developers?
It decouples the policy decision from the application logic instead of the developer writing complex if-else statements for security inside their service.
They just ask OPA.
Right. The application gathers the relevant attributes, who the user is, what they're trying to access, packages it as JSON, and sends it to the OPA engine. OPA evaluates the query against its loaded policies and just returns a simple decision, true or false, allow or deny.
So the microservice doesn't need to know why the decision was made, just what it is. And the security team can update the policies in OPA centrally without redeploying all the applications.
That's the power. Centralized policy management, decentralized enforcement. Hugely important for scalable and agile systems.
Okay, that concept of centralization versus decentralization brings us nicely to the protocols and architecture needed to handle IAM at scale. Let's start with single sign-on, SSO. Seems table stakes now.
Absolutely essential, both for security and user experience. FSO means users log in once to an identity provider.
And then get access to multiple applications without logging in again.
Right. It dramatically reduces password fatigue and the dangerous habit of reusing passwords across different sites. Fewer passwords mean a smaller attack surface.
Now let's clarify the big protocols involved here because they often get confused. Oath 2.0, OpenID Connect, OIDC, and SAML 2.0.
Okay, let's nail this down. Oath 2.0 is the industry standard for delegated authorization, not authentication.
Delegated authorization, meaning like when I let a third-party app access my Google Photos.
Exactly. You're granting that app permission to access your photos on your behalf, but you're not giving it your Google password. Oath defines how that permission grant, the token, works. It's about granting access, not proving identity.
Okay, so Oath is the permission slip. Then what's OpenID Connect, or OIDC?
OIDC is specifically the authentication layer that's built on top of Oath 2.0. It uses the Oath flows but adds an ID token, usually a JWT, that contains verifiable information about the user's identity.
So OIDC answers the who are you question using Oath's plumbing.
Precisely. It provides that identity verification and basic profile info. Because it uses JSON and JWTs, it's the preferred modern standard for web apps, mobile apps, SPAs. Much simpler than SAML.
Which brings us to SAML 2.0, the older standard.
Yep, SML 2.0 is the established workhorse, especially for enterprise SSO and federation between organizations. It's XML-based, which makes it more verbose and sometimes complex compared to OIDC.
But still widely used in corporate environments.
Very much so. It's mature, secure, and deeply embedded. You'll definitely encounter it. But for new projects, especially mobile or API-focused, OIDC is generally the way to go.
Okay, protocol is clear. Now, architecture in a microservices world. If you have dozens, maybe hundreds of services, having each one handle token validation and authentication seems inefficient and risky.
It's hugely risky. Each service becomes a potential weak point. It duplicates logic, increases the chance of implementation errors. Just bad practice.
Okay, so what's the pattern?
The standard recommended pattern is using an API gateway.
The gateway acts as the front door for everything.
Exactly. It's the single entry point for all external requests into your system. And crucially, you configure the API gateway to handle the centralized authentication at the edge.
So the request comes in, hits the gateway.
The gateway intercepts it. It validates the JWT token, checks the signature, the expiration, the issuer. It basically performs the authent check right there.
And if the token is valid,
Then the gateway can securely pass the validated identity information like the user ID, roles, maybe other claims from the token downstream to the specific microservice that needs to handle the request, usually in a trusted HTTP header.
so the individual microservices don't need to worry about validating the JWT anymore. They just trust the info passed by the gateway.
Correct. This is a critical separation of concerns. The gateway handles authn. The downstream microservices can then focus purely on their business logic and, importantly, on the fine-grained authorization, authz, based on the identity information they received.
That makes perfect sense. Centralize authn at the edge, distribute authz deeper in the system.
That's the pattern. It simplifies the services, improves security, and scales much better.
This focus on context and dynamic checks feels like it leads directly into future trends. Zero trust isn't just a buzzword anymore, is it?
No, it's really an architectural mandate now. Google's Beyond Corp initiative was arguably the pioneer here, showing it could be done at massive scale.
And the core idea of zero trust, or Beyond Corp, is
Never trust. Always verify. Basically, you throw out the old idea of a trusted internal network perimeter. Access decisions are made based on the user's identity, the health and posture of their device, and the context of the request itself.
regardless of whether they're inside or outside the traditional network boundary.
Exactly. Every single request, even service-to-service communication internally, must be authenticated and authorized. It's a direct application of dynamic, attribute-based access control principles.
Another major trend the sources highlight is the move towards passwordless authentication. Is this really happening?
It has to. Passwords are fundamentally a flawed security mechanism. They get phished, guessed, stolen in breaches, reused. They're the weakest link.
So things like biometrics, Face ID, security keys, passkeys.
Yes. Technologies like WebAuthn and FIDO2 are enabling truly passwordless experiences. It's not just better security, it's often a better user experience too. And think about the operational savings.
How so?
Help desk costs. A huge percentage of IT support calls are for password resets. Eliminating passwords cuts that cost dramatically. So there's a strong business case alongside the security one.
Okay, makes sense. And the last future trend, which sounds potentially the most disruptive, is decentralized identity, or DDI.
DD is fascinating. It aims to flip the current model on its head using technologies like blockchain and verifiable credentials.
How does it flip the model?
Right now, our identities are largely held by centralized providers, governments, big tech companies. With DD, the idea is that the individual owns and controls their own digital identity credentials.
So my university degree, my driver's license, my vaccination record, they become verifiable digital credentials I hold in my own secure digital wallet.
Exactly. And when you need to prove something, say, prove you're over 18 to buy something online, you present the relevant credential from your wallet. The relying party can then cryptographically verify its authenticity and issuer.
Without needing to ping a central database or the original issuer every time, and potentially without revealing more information than necessary.
Precisely. It promises much greater user privacy and control and significantly reduces the risk associated with massive breaches of centralized identity databases. It shifts control back to the individual.
Wow, that sounds like a fundamental shift. Okay, this has been incredibly insightful, covering the whole life cycle from basic authnacy distinctions to these future concepts like DID. Let's try and boil this down. What are the key strategic takeaways for someone building or managing systems right now?
Okay, number one has to be that architectural separation. Centralize your authentication. Use an identity provider and force it at the API gateway. But distribute the authorization enforcement down to the individual services that own the resources.
Makes sense. What's number two?
Embrace the necessary complexity for flexibility. Implement that hybrid RBAC model. Use RBAC for structure, ABAC for the fine-grained context-aware rules, and manage those rules using policy as code packed tools like OPA.
Right, treat policy like code. And the third takeaway?
Modernize your protocols and look ahead. migrate new applications to OIDC instead of older protocols where possible, and critically, start actively planning for and migrating towards a passwordless future. It's not if, but when.
So the bottom line is modern security isn't a static wall anymore. It's this dynamic, layered, context-aware system, almost like a nervous system, as you said at the start.
It has to be. It needs to adapt and enforce rules based on real-time context.
Which leads us to our final provocative thought for you, the listener, thinking about that decentralized identity concept.
Yeah, if DDA truly takes hold and identity verification becomes user-controlled, cryptographically secured, maybe using blockchain, how might that fundamentally change our reliance on or even the need for centralized government or corporate identity systems over the next, say, 10 years?
What happens when proof of identity is something you hold, not something granted or managed solely by large institutions? Something to definitely ponder.